Hello, hello, hello. Yes, hello everyone. Welcome on YourPedia platform. I hope you are fine. So, guys, I am Vishal Sharma, and again, I'm here in front of you with some of the important thermodynamics question for our upcoming examination, BHEL and HPCL, guys. So, very good question we are going to solve from this subject, thermodynamics. I hope you are having some basic understanding related to this subject. Otherwise, from very basic, we will discuss all related concept also. So even if you are a beginner, then also you are going to get very good advantage out of this class, guys, because all related concept I am going to discuss. But yes, if you are having some good fundamental understanding, then yes, you will be able to practice very good quality questions with me. So let's start our discussion, guys. So I'm here going to share some of the questions with you. Question will be visible to you on the screen, and you need to try with me, guys. So it's my request to all of you. Please try each and every question. And yes, your responses matters a lot, guys. You all are mechanical engineer, and you all understand the function of a lubrication. Okay, and what you can say. For a teacher also, if you are putting your comments, if you are answering, then yes, then also a teacher feels yes, students are getting, and we will be able to maximize that kind of energy conversion process. So it's my request to all of you guys, please respond, okay, and try each and every question, because if you are trying, that is a kind of satisfaction for a teacher. Okay, I hope you can understand that. So answering right or wrong, that doesn't matter, okay, but you are trying or not, that matters a lot. So please keep trying. Thank you, good luck. चलिए शुरू करते हैं. So this is the question number one, guys, in front of you. First question in front of you, guys. Question number one. So the internal energy of an ideal gas. This is gas. तो मैं इसको correct कर देता हूँ. The internal energy of an ideal gas. Internal energy of an ideal gas increases during an isothermal process. When the gas is. So there are four options given, guys. Please respond and try to answer. Very simple, direct question in front of you. Please read the question, try to answer. Okay, guys, I'm picking all questions related to what? BHEL and HPCL. Okay, I'm not taking a kind of high level, gate level question. So वो NPTEL series also soon we are going to start. Okay, after 10-15 days, we are going to start. We are thinking of starting NPTEL series also, that we started last year. But okay, and in that series we will solve very good quality questions related to gate also. दो बच्चों ने आंसर किया बी, expanded by adding more heat to it. Expanded by adding more heat to it. Guys, you know, dq equal to du plus dw. dq equal to du plus dw. Yes or no? For an ideal gas, internal energy of an ideal gas is a function of temperature only. It is a function of temperature only. So if temperature is constant, for temperature constant, the change in internal energy of an ideal gas will be zero. There will be no change in the internal energy. For an ideal gas, if temperature constant, there will be no change in the internal energy. So what he mentioned, the internal energy, kiska? Ideal gas ka, during an isothermal process. So how you can change the internal energy of an ideal gas? By adding more heat. If you are adding more heat, you will get more work. Because for an isothermal process, du is zero, so dq equal to dw. If you are adding heat in an isothermal process, you will get more work. If you are giving, if you are rejecting heat, you will need to, what we can say, you need to do the work. So if this is positive, heat addition positive, you are going to get the positive work. If heat rejection negative, you need to give the work in an isothermal process. So by compressing or by what you can say giving work, by giving heat, you cannot change internal energy if the process is isothermal. Isothermal may you can only change the internal energy if the mass is changing, guys. So number of moles are changing. So answer will be what? Expanded by adding more molecules. So you need to read, guys. Question is very simple. Only you need to read the entire question, guys. If you are expanding a gas by adding more heat, more molecule, guys, you know how we can define internal energy? That is mcp/dt. Okay, so yes, if there is no change in temperature, there will be no change in internal energy. But internal energy is a kind of what? It is a kind of extensive property. Internal energy is an extensive property, means more is the mass, more will be the internal energy. Okay, and if you want to represent the internal energy for a one mole of a substance, 1 mole of substance का internal energy क्या होता है बच्चों? That is nothing but the kinetic energy of the gas molecule. तो internal energy 1 mole का, 1 mole gas का internal energy क्या होता है? That is nothing but n/2 RT. You know, guys, this formula you know. Kinetic energy, internal energy of one mole of a substance, that is nothing but n/2 RT, where n is the degree of freedom. Okay, kinetic theory of gases में जरूर आपने कहीं पढ़ा होगा 11th 12th में, n/2 RT. That's why we say internal energy is a function of temperature only for an ideal gas. Okay, तो आंसर इसका A होगा बच्चों. Only one student answered this question, Vivek, and your answer is very right, guys. चलिए, I hope you got the idea. ठीक है, इनमें से किसी में भी इंटरनल एनर्जी चेंज नहीं होगा. इंटरनल एनर्जी इज गोइंग टू चेंज इन ए आइसोथर्मल प्रोसेस ओनली when you are adding, when you are changing the mass, adding or removing. चलिए, नेक्स्ट क्वेश्चन है बच्चों आपके सामने, सेकंड क्वेश्चन इन फ्रंट ऑफ यू. अगेन इट्स माय रिक्वेस्ट टू ऑल ऑफ यू गाइस, प्लीज कीप ट्राइंग. चलिए, तरुण, अभिषेक, वेरी गुड, आपने बच्चों रिस्पॉन्ड किया, मींस यू आर डिफरेंट, यू आर आउट ऑफ द रिमेनिंग 14-15 स्टूडेंट्स. तो ट्राई करना इज गुड, गाइस. Ideal gas is taken around the cycle ABCD as shown in the figure. ABCD is a cycle. The cycle is shown as ABCD. तो यहाँ पे वॉल्यूम कितना है V1, यहाँ पे वॉल्यूम कितना है 3V1, यहाँ पे प्रेशर है P1, यहाँ पे प्रेशर है 6P1. So this is pressure versus volume diagram, and the cycle is going like this, guys. ABCA. आपसे क्या पूछ रहा है? The net work done by the gas during the cycle. Net work done by the gas during cycle. Guys, net work done क्या होता है? On PV diagram, the closed area of the cycle on PV diagram gives us net work. On TS diagram, the closed cycle area gives us the net heat transfer, and the closed area of a cycle on PV, that is equal to closed area on TS. Why? Because according to first law of thermodynamics, energy we cannot create, we cannot destroy. That's why net heat transfer equal to net work transfer. तो यहाँ पे इसका एरिया क्या हो जाएगा बच्चों? एरिया विल बी हाफ, बिकॉज एज यू कैन सी इट्स अ राइट एंगल ट्रायंगल. सो हाफ बेस विल बी व्हाट? 3V1 minus V1, so it will be 2V1. Base into height is 6P1 minus P1, so it is 5P1. So this 10, this will cancel out, so you will get 5P1 V1. This is what W net. In this cycle, the W net is the closed area, this particular area, and this will be 5P1 V1. So answer C हो जाएगा बच्चों. Very good. चलिए, let us move to next question, question number 3. Please try to answer. Very good, guys. Lots of students actually answered this question. Lucifer, Tarun, Vivek, Abhishek, Ajay. Guys, very good. चलिए, third question in front of us. In which of the following process a maximum increase in entropy is observed? What is entropy, guys? Entropy is a measure of disorder or randomness of the molecule. Okay, more is the randomness, more is the disorder. चलिए, in which of the following process maximum increase in entropy is observed? किस प्रोसेस में एंट्रोपी का चेंज मैक्सिमम होगा? तो क्या क्या ऑप्शन है? डिसॉल्विंग साल्ट इन वाटर, कंडेंसेशन ऑफ वाटर, sublimation of naphthalene, melting of ice. So in which case the entropy change will be maximum? Third question in front of us, guys. चलिए, एक बच्चे का आंसर आया है, तरुण का A आया है, and Abhishek is saying C. I am waiting for some more responses, guys, then we will proceed. Vivek is saying B, condensation. Asharni, ये क्या है? SC Reddy. Yes, SC Reddy Kona is saying D. Vivek is saying C. Ajay Thoram is saying C. Now most of the people are saying C, guys, and guys, those are thinking of C, they are very right, because this is the right answer. Guys, what is entropy? Entropy is a measure of disorder or randomness, and for a phase change process, you know, For a phase change process, ds equal to dq by t. We can write it as, for a reversible process, ds equal to dq by t reversible. As we are increasing the temperature, जैसे जैसे टेम्परेचर बढ़ता है एंट्रोपी बढ़ता है, डिसऑर्डर रेंडमनेस बढ़ता है, जैसे जैसे फेज चेंज होता है, गाइस एंट्रोपी ऑफ सॉलिड का जो एंट्रोपी है is less as compared to entropy of water, and it is less as compared to entropy of gas. एंट्रोपी गैस का क्या होता है बच्चों, ज्यादा होता है, जैसे जैसे फेज बढ़ेगा एंट्रोपी बढ़ेगा. सो हियर इफ यू विल चेक, here what you are doing, you are dissolving. He has not given you any kind of quantitative measures. In general common sense, common way, he is asking, guys, he has not given you any amount of salt. He is not saying you are millions of, what you can say, pound of salt you are immersing in some sea. It is not like that. He has not given you any data. In general way he is asking you. So here it's a kind of mixing process. Yes, mixing is a highly reversible process. Entropy generation is going to take place. But here if you will check, you are carrying out the condensation, means phase is changing, and due to phase change, again the liquid is having very less entropy as compared to the vapor. So vapor is converting into liquid, entropy change will be there, and that will also be more huge. Here phase change is taking place. But here the sublimation process is what? It's a change in phase from a solid directly to vapor. So from a solid which is having very less entropy, okay, solids mein molecules kya hote hain, randomness, disorder is very less as compared to what? Gas is having high huge entropy. So when you are converting solid directly to vapor, the entropy change will be huge. That's why this is the right answer, guys. So sometime it is observed in these kind of examinations like HPCL BHEL, you are going to get these kind of common sense question, guys. So you need to apply your mind and you need to answer these kind of question. Chaliye, let us move to next question. Question number 4. क्वेश्चन नंबर 4 इन फ्रंट ऑफ अस. तो इसको मैं थोड़ा सा चेंज कर देता हूं. दिस इज del u equal to w. So these are the this is the question, guys. Please read the entire question and try to answer. Based on the first law of thermodynamics, which one of the following is correct? इनमें से कौन सा करेक्ट है बच्चों? Based on the first law of thermodynamics, which one is correct? For an isothermal process, Q equal to W. For an isochoric process, delta U equal to minus Q. For an adiabatic process, delta U equal to W. For a cyclic process, Q equal to minus W. Yes, guys, please try to answer. Gacha Rose is saying C. Asiredi Kona is saying A. Abhishek is saying A. Pappu is also saying A. So lots of students are saying A. 1-2 students are saying C. चलिए, based on first law of thermodynamics, guys, what is first law of thermodynamics? For a process, how we can write? dq equal to de plus dw. This is first law of thermodynamics for any system, any process. Any system, any process. Any system, any process. Okay, if you take the kinetic energy changes, if you neglect, okay, or if you take a kind of closed stationary system, for a closed stationary system, so for a closed stationary system, any process, this is the equation, guys. This is the equation of first law of thermodynamics for a closed stationary system. Okay, now if you'll observe it here, guys, if you can write it here, Q as a Q heat transfer, this is delta U change in internal energy, this is what? W work transfer. So this is the differential form, guys. This is the differential form, and this is what? Q heat transfer, change in internal energy, work transfer. Okay. So for an isothermal process, guys, अब देखो उसने हालांकि he is not going to mention every time कि ideal gas है. We are going to take it as an ideal gas only. So for an ideal gas, process is isothermal. So dq will be 0. So yes, Q is equal to W. This is very right. Q equal to W for a isothermal process, guys. If you are adding it, you will get the positive work. If you are rejecting it, you need to do the work on the system. Okay. So this is very right. For an isochoric process, isochoric means a rigid container, constant volume. Okay, तो constant volume के लिए क्या होता है? Work क्या होगा? 0. Work, reversible work is PdV. Closed system reversible work is PdV. And if change in volume is 0, boundaries of a closed system are not changing. Work will be 0 in a closed system. Okay, तो work 0 हो जाएगा. तो Q equal to W. यहाँ पे क्या है? Minus sign है, which is not right. You can observe it here, guys. Delta Q equal to minus Q, which is not right. ये सही नहीं है. Adiabatic process के लिए तो हीट ट्रांसफर क्या होगा? 0 होगा. That's why you will get delta Q equal to minus W. Delta U equal to minus W. But यहाँ पे क्या है बच्चों? Delta U equal to plus W. That's why this is also not right. For a cyclic process, cyclic integration of heat q net heat transfer that is equal to net work transfer. अगर नेट हीट ट्रांसफर पॉजिटिव होता है बच्चों, नेट वर्क ट्रांसफर भी पॉजिटिव आएगा. इफ नेट हीट ट्रांसफर इज नेगेटिव, नेट वर्क ट्रांसफर विल आल्सो कम आउट नेगेटिव. Okay, so q is not equal to minus w, q is equal to w for a complete cycle. So this is also not right. So only equation 1 is right. That's why option A is the right answer for this question, guys. Very good. So those actually answered this A, they are very right. Chaliye next question. Question number 5. Question number 5, guys. It's a kind of match the following, match the list case. बहुत टिपिकल क्वेश्चन है बच्चों फॉर पीएसयू. तो ये डिफरेंट प्रोसेसेस दिए हैं. दिस इज प्रोसेस 1, ये 1 है, ये 2 है, ये 3 है और ये 4th प्रोसेस है. दिस इज 1 वर्टिकल लाइन, दिस इज 2, दिस इज 3, दिस इज 4. तो आपसे क्या पूछ रहा है, मैच करने के लिए बोल रहा है प्रोसेस 1. दिस इज पीवी डायग्राम गाइस, दिस इज प्रेशर वर्सेस वॉल्यूम डायग्राम. प्रेशर वर्सेस वॉल्यूम डायग्राम. तो आपको मैच करना है प्रोसेस 1. प्रोसेस 1 क्या है बच्चों? प्रोसेस 1 इज ए कांस्टेंट वॉल्यूम प्रोसेस, आइसोकोरिक. प्रोसेस 1 क्या है आपका? आइसोकोरिक, कांस्टेंट वॉल्यूम. प्रोसेस 2 क्या है बच्चों? व्हाट इज प्रोसेस 2? इट इज आइसोथर्मल. दीज आर द आइसोथर्मल लाइन गाइस. ये जो लाइन आपको दिख रही है, दीज आर कांस्टेंट टेंपरेचर लाइन गाइस. दीज आर कांस्टेंट टेंपरेचर लाइन. सो 2 इज नॉट कांस्टेंट टेंपरेचर. 2 कांस्टेंट टेंपरेचर नहीं है. एंड इवन द स्लोप ऑफ दिस इज मोर देन कांस्टेंट टेंपरेचर. तो ये क्या होगा? दिस विल बी एडियाबैटिक. तो 2 क्या है आपका? एडियाबैटिक. प्रोसेस 3 क्या है? प्रोसेस 3 इज आइसोथर्मल एंड प्रोसेस 4 इज व्हाट? दिस इज आइसोबारिक. तो क्या मैच करेगा? P इज मैचिंग विद C, Q इज मैचिंग विद A, R इज मैचिंग विद D एंड S इज मैचिंग विद B. सो ऑप्शन B क्या है बच्चों? दिस इज द राइट आंसर. ऑप्शन B इज द राइट आंसर फॉर दिस क्वेश्चन गाइस. आपको थोड़ा सा क्विक रहना पड़ेगा इस तरह के क्वेश्चन में. क्वेश्चन बहुत आसान है. ओनली यू नीड टू रीड द एंटायर क्वेश्चन. ओके, प्रेजेंस ऑफ माइंड अच्छा रखना है. ओके, चलिए नेक्स्ट क्वेश्चन इन फ्रंट ऑफ अस, क्वेश्चन नंबर 6. Question number 6, guys. Please try to answer this question. Let me read it for you. If an ideal gas undergoes two processes at constant volume, so the process is constant volume पे ideal gas is undergoing constant volume process, and for that PT plot is given. Okay, PT plot is given for a process of a ideal gas at constant volume, and he is asking you this process is at constant volume V1, this process is at constant volume V2, then what is the relationship between V1 and V2? What is the relationship between V1 and V2? V1 equal to V2, V1 greater than V2, V1 less than V2, या V1 is greater than equal to V2? Read and try to answer, guys. चलिए आंसर मिलने शुरू हो गए हैं. बच्चे ने, तरुण ने आंसर किया B, अजय सिंह B, Vivek is saying A. चलिए, most of the people are saying B, guys. But B क्या ठीक है यहाँ पे? B क्यों? आप सोचो एक बार, अपने आप से पूछो, why you are answering B? What is the reason behind that? Guys, that thing you need to ask to yourself. अभी नहीं सोचोगे तो एग्जाम में सोचने का टाइम नहीं मिलेगा. Why? It's fine. It's fine. You can answer A, B, C, anyone. But try to ask yourself why actually you are thinking of B. Means you are just guessing, random guessing, or you are having some solid base of going with this option B. If you are randomly guessing, guys, that is not right, guys, because by guessing you will not be able to crack this kind of examination. 2-4 नंबर का 5 नंबर का फर्क पड़ सकता है, बट गेस करके क्रैक तो नहीं कर पाओगे बच्चों. चलिए, तो अभी देखते हैं बच्चों क्या होता है आइडियल गैस. आइडियल गैस क्या होता है बच्चों? आइडियल गैस विच फॉलोज आइडियल गैस इक्वेशन, PV इक्वल टू MRT. तो वॉल्यूम कांस्टेंट है, तो कैन आई राइट इट एज P इक्वल टू MR बाय VT, या लिख सकता हूं मैं P इक्वल टू CT. सो डेफिनेटली for a constant volume process on PT curve, the line is going to pass through the origin. So plot is very right. Plot बिल्कुल सही है बच्चों. The plot is very right. Constant volume lines, they are going to pass through the origin because the intercept on the y-axis is 0. You can check it here. This is what? This is y. This is the slope m. This is what? X. Y equal to mx plus c. So c is the intercept on y-axis, which is 0. M is the slope. T is x. So this is pressure y versus x temperature plot. So P equal to Ct plus 0. Intercept on y-axis is 0. Now can you check here guys, what is this slope? ये slope कितना है बच्चों? This slope is nothing but mr by v. So more is the volume, less will be the slope. More is the volume, less is the slope, guys. That's why I asked you why you are thinking of B, guys. Why not C? Because जितना वॉल्यूम ज्यादा है उतना स्लोप क्या होगा, कम होगा. That's why V2 is greater than V1, guys. V2 V1 से ज्यादा है, बिकॉज जितना वॉल्यूम बढ़ेगा स्लोप घटेगा बच्चों. Slope is inversely proportional to volume. More is the volume, less is the slope. That's why C is the right answer for this question, not D. Please check and tell me, is it clear, guys? Ashrinidhi, Kona, Vishnu, Vardhan, Abhinav, Kavade. Guys, your all answers are very right. पप्पू, विवेक, अभिषेक, आप अभिषेक का आंसर भी ठीक है. ऋतिक, आपको चेक करना है, आपका आंसर ए इज नॉट राइट. ठीक है. अजय, तरुण, जिन्होंने बी आंसर किया था, दैट इज आल्सो नॉट राइट गाइस. सो प्लीज चेक अगेन. इफ इट इज क्लियर देन फाइन, वी आर गोइंग टू मूव टू नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 7. Question number 7, guys, in front of us. Let me read, try to answer. Question number 7. In a thermodynamic process, pressure of a fixed mass of a gas is changed in such a manner that the gas releases 30 joule of heat. This is heat, guys. कई बार typing mistake हो जाता है. 30 joule of heat and 10 joules of work was done on the gas. If the internal energy of the gas was 30 joule, initial internal energy was 30 joule, then what is the final internal energy? Very typical question, guys. Typical PSU questions. बहुत बार ऐसे क्वेश्चन पूछे जाते हैं. हर लेवल का क्वेश्चन, गाइस, वी आर कवरिंग. दिस इज क्लास 2 फॉर थर्मोडायनेमिक्स. फर्स्ट क्लास वाज देयर थ्रू जूम. दिस इज सेकंड क्लास ऑन यूट्यूब चैनल, YourPedia YouTube channel. So 4 classes I think we will have for thermodynamics, and in those 4 classes all different type of question we are planning to cover from this subject, thermodynamics. चलिए. So guys, you know first law of thermodynamics, dq equal to du plus dw. Okay, dq equal to du plus dw. So but you need to use this equation is very simple, but when you are writing this equation, if you are putting some value here, some magnitude value you are putting, so you need to use the sign convention. Heat addition to the system, positive. Work done by the system, positive. Work done on the system, negative. Heat rejected by the system is negative. These are the sign convention. Added to the system heat, positive. Heat rejected by the system, negative. Work done by the system, positive. Work done on the system, negative. These sign convention you need to follow. तो क्या बोल रहा है बच्चों? Gas released this much of energy. So 30 joule is the energy going out of the system. So this is minus 30. 30 joule is the amount of heat going out of the system. 10 joule of work was done on the gas. So this is also negative. Yes or no? Gas released 30 joule of heat, means that is a heat rejection by the system, minus 30. 10 joule of the work was done on the gas, means work is done on the system. So delta U क्या हो जाएगा बच्चों? Minus 30 plus 10, that is equal to delta U. So that is nothing but U final minus U initial. Okay, so minus 20, that is equal to U final minus how much is U initial, guys? U initial is 30. तो U final कितना जाएगा बच्चों? Final internal energy is 10 joule. Final energy कितना जाएगा? 10 joule. So C is the right answer for this question, guys. Very good, Ajay, Vivek. Very good, guys. Abhishek, बहुत सारे बच्चों ने C आंसर किया. It's good. C is the right answer for this question, guys. Others also, please keep trying. Next question in front of us, question number 8. A gas undergoes a change of state. A gas undergoes change of state during which 100 joule of heat is supplied to it. 20 joule of work is done. It does 20 joule of work, means this is positive work, guys. Plus W. Plus W. Heat is supplied. This is plus 100. This is also plus because heat supplied to the system. The system brought back to, this is 2, guys. System brought back to its original state. The system brought back to its original state through a process during which 20 joule of heat is released, minus 20. Okay, the gas, work done by the gas. तो आपसे क्या पूछ रहा है? Work done by the gas. So this W पूछ रहा है आपसे. So system is going from state 1 to 2. 1 to 2 जा रहा है बच्चों. और फिर आप क्या कर रहे हैं? You are reversing back. You are reversing back it from what? 2 to 1. 1 से 2 जा रहा है. और 2 to 1 आप क्या कर रहे हो, रिवर्स कर रहे हो. So guys, it means you are constituting a cycle. You are constituting a cycle. When you are going from 1 to 2, again returning back to 1, it means you are constituting a cycle. And in any complete cycle, the change in any property, guys, change in any property in a complete cycle is zero, guys. Whether it is internal energy, pressure, temperature, volume, entropy, any property, because properties are state function, properties are point function, that does not depend on the path. If you are going via some particular cycle, if you are reaching to the same state, it means there is no change in the properties in a complete cycle. So what we can say, guys, or we can say internal energy change 1 to 2 plus internal energy change 2 to 1, that is what, 0, or internal energy change 1 to 2, that is equal to minus internal energy change 2 to 1. ओके, चलिए. तो गाइस पहले केस में 1 to 2, हाउ मच इज द हीट एडिशन, हीट ट्रांसफर, दिस इज प्लस 100, सो हीट ट्रांसफर Q इक्वल टू डेल्टा U प्लस W. ओके, सो दिस इज डेल्टा U 1 to 2. वर्क पे क्या है, दिस इज आल्सो पॉजिटिव. तो U 1 to 2 कितना है बच्चों, U 1 to 2 is 80. This is we are writing for 1 to 2, guys. So for 2 to 1, Q इक्वल टू U प्लस DU प्लस W. तो Q कितना है बच्चों, हीट इज -20, डेल्टा U कितना हो जाएगा, दिस इज -80 प्लस वर्क. तो वर्क कितना आ जाएगा, इट विल बी -20 प्लस 80, सो इट विल बी 60. वर्क डन बाय द सिस्टम इज 60 जूल. ओके, वर्क डन बाय द सिस्टम इज 60 जूल, एंड दैट इज पॉजिटिव, गाइस. So when you are returning back via 2 to 1, the work will be done by the system, guys. 60 joule is the work done by the system. Got the idea, guys? Please check. तो साइन कन्वेंशन का ध्यान रखना है बच्चों, साइन कन्वेंशन ध्यान रखना है. दिस इज U1 to 2 इक्वल टू U2 to 1. ये मत कर देना कि सर U1 to यहां से यहां इंटरनल एनर्जी जो चेंज होगा वही यहां पे होगा. इफ यू आर नॉट टेकिंग साइन, यू आर नॉट गोइंग टू गेट द राइट आंसर, गाइस. यस, मैग्नीट्यूड वाइज दे आर सेम. U1 to 2 that is equal to U2 to 1 magnitude, but their signs are different, guys. So if you are comparing, अगर आप क्या कर रहे हो, इसका U1 to 2 ले रहे हो, इसका U2 to 1 ले रहे हो, and you are comparing them, then you will not get right answer. Answer will be wrong, guys. You are going to get the right answer only if you are taking the sign also, guys. U1 to 2 plus U2 to 1, that is equal to 0. So U1 to 2, that is equal to minus U2 to 1. Answer will be 60 joule positive work. Next question in front of us, question number 9. वेरी गुड क्वेश्चन, गाइस. ये बहुत अच्छा क्वेश्चन है. देखते हैं कितने बच्चे इसको आंसर कर पाते हैं. दिस इज क्वेश्चन नंबर 9 इन फ्रंट ऑफ अस. सो दिस इज गिवन टू अस, गामा इक्वल टू 3.2. तो क्या बोल रहा है, लेट मी रीड इट फॉर यू. थ्री सैंपल्स ऑफ द सेम गैस ABC. Three samples of the same gas. Same gas means they are having same property. Gamma is same for all the gases. Three samples of same gases ABC have initial equal volume. सबका initial volume क्या है, सेम है बच्चों. All gases they are having same initial volume. Now the volume of each sample is doubled. हर एक का volume double हो गया बच्चों. Okay. But process क्या है, different है. In vessel A the process is isobaric. In vessel A the process is isobaric. अच्छा, for adiabatic, for A it is adiabatic, for B it is isobaric, for C it is isothermal. A के लिए क्या है बच्चों, adiabatic. B के लिए क्या है, isothermal. और C के लिए क्या है, अच्छा B के लिए isobaric और C के लिए isothermal. Isobaric और इसके लिए isothermal. ओके. इनिशियल वॉल्यूम सबका सेम है, V इनिशियल सेम है सबके लिए, V फाइनल भी सेम है, V फाइनल भी क्या है, सेम है. और ये कितना है, दिस इज 2V1, ट्वाइस ऑफ V1. आपसे पूछ क्या रहा है बच्चों, व्हाट इज आस्किंग यू, इज आस्किंग यू द प्रेशर. द फाइनल प्रेशर आर इक्वल. फाइनल प्रेशर भी सेम है बच्चों, सबका फाइनल प्रेशर भी क्या है, सेम है. सबका फाइनल प्रेशर भी क्या है, सेम है. बट व्हाट इज नॉट सेम, द इनिशियल प्रेशर. इनिशियल प्रेशर्स आर नॉट सेम. सो व्हाट इज आस्किंग यू, द रेशियो ऑफ देयर इनिशियल प्रेशर्स. इनके इनिशियल प्रेशर्स का रेशियो पूछ रहा है बच्चों. इनिशियल प्रेशर ऑफ ए, इनिशियल प्रेशर ऑफ बी, इनिशियल प्रेशर ऑफ सी. इनिशियल प्रेशर ऑफ ए बी सी, गाइस, इनका रेशियो पूछ रहा है बच्चों. व्हाट इज द इनिशियल प्रेशर ऑफ ए बी सी, द रेशियो ऑफ इनिशियल प्रेशर ऑफ ए बी सी, गाइस, is asking you the ratio of initial pressure of ABC. So guys, question is very simple. Let me take it here, write it here. थोड़ा सा मैं इसको मिनिमाइज कर देता हूं. So guys, A प्रोसेस क्या है, एडियाबैटिक. तो एडियाबैटिक प्रोसेस के लिए क्या होता है बच्चों, प्रेशर चेंज क्या होता है, व्हाट इज प्रेशर चेंज, you know P2 by P1, या चलो हमें इनिशियल प्रेशर चाहिए, वी वांट द इनिशियल प्रेशर, सो लेट मी राइट इट एज V1 by V2, P1 by P2, P1 by P2, this is nothing but what, V2 by V1 की पावर गामा, yes or no? P1 by P2 that is equal to V2 by V1 की पावर गामा. This is for what? Adiabatic process, a reversible adiabatic process. Okay, तो P1 क्या आ जाएगा बच्चों, या इसको लिख रहा हूं मैं PA, because this is for process, this is for the container A where adiabatic process is taking place. So PA, P2 is same guys, सबके लिए P2 क्या है, final pressure is same, and I am representing that final pressure by P only guys. Final pressure I am representing by P only. So can I write this PA equal to P, and V2 is 2 times, so this is 2 की power gamma, and gamma is nothing but 3 by 2. So can I write it as 2 का cube, it will be 8, it will be 2 under root 2P. Yes or no guys? So final pressure for A is this. Sorry, initial pressure guys. Initial pressure for A. This is initial pressure for A guys. This is P1 guys. So this is A or what, P1. Okay. Initial pressure for A is 2 under root 2P. Similar way, for the second process, isobaric. The process is isobaric. अगर प्रोसेस आइसोबारिक होगा तो आइसोबारिक के लिए क्या होता है बच्चों, व्हाट इज द रिलेशनशिप बिटवीन प्रेशर और आइसोबारिक, प्रोसेस ही आइसोबारिक है, तो मैं डायरेक्टली लिख देता हूं क्या, Pb इक्वल टू P ओनली गाइस. Pb इक्वल टू व्हाट, P. Initial pressure of the B that is equal to final pressure of B. B का आइसोबारिक में, प्रोसेस इज आइसोबारिक, सो फाइनल प्रेशर क्या है, फाइनल प्रेशर हर एक का क्या है, P है सेम. सो इनिशियल प्रेशर ऑफ B that will also be P only. So this is for what guys, this is for B, second container B, isobaric. Okay, now if you want to find out 3 PC, isothermal, for isothermal temperature constant, so VT equal to constant, or what you can say P1 V1 that is equal to P2 V2, या मैं यहां से लिख सकता हूं PC, this is the initial pressure of C that is equal to what guys, final pressure P into V2 by V1, this is nothing but 2. So can I write here PC equal to 2P guys? PC equal to 2P. So initial pressure of A is 2 under root 2P. Initial pressure of B is P. Initial pressure of C is this. And what we want guys, we want this ratio. So this is nothing but ratio what guys, 2 under root 2P ratio what, P ratio 2P. So what I will get out of this guys, P is same, P is common for all, the ratio will be what guys, under root 2 under root 2 ratio 1 under into 2. So answer will be what guys, option B is the right answer. Please check again and tell me if it is clear to you or not guys. Option B is the right answer for this question. So those are getting option B, they are very right. थोड़ा सा अच्छा क्वेश्चन था, डिफरेंट है, एक आध क्वेश्चन हमें ऐसा भी करना चाहिए just to apply our mind guys. Okay, study is a kind of practice guys. जिम में हम एक्सरसाइज करते हैं, people they try to lift the weight 200 250 kg. In real life it may be the case they will not be able to lift even in competition 180 or 190 kg, but practice हमें करनी चाहिए बच्चों. चलिए, because output will always be less than input, that is the second law of thermodynamics. Okay, 100% conversion is impossible. चलिए, so next question in front of us, question number 10. 1 gram of ice, 1 gram of ice at 0 degrees Celsius is mixed with 1 gram of water at 100 degrees Celsius. The resulting temperature will be, you need to approximate some approximate answer guys, you need to give. 1 ग्राम वाटर को, 1 ग्राम आइस को, 1 ग्राम आइस एट 0 डिग्री सेल्सियस आपने मिक्स कर दिया 1 ग्राम वाटर एट 100 डिग्री सेल्सियस, फाइनल टेम्परेचर क्या होगा. क्वेश्चन बहुत सिंपल है, एक लाइन का क्वेश्चन है, बट ऑप्शंस भी देखो, ऑप्शन भी सिंपल है. अगर ऑप्शन डिफिकल्ट होते तो क्वेश्चन बहुत डिफिकल्ट बन जाता बच्चों. ये ऑप्शंस बहुत इजी हैं, सिंपल हैं. ओके, क्योंकि देखो फाइनल टेम्परेचर ना तो जीरो हो सकता ना ही इन्फिनिटी हो सकता, तो ये दो तो आप ऐसे ही हटा सकते हो. फाइनल टेम्परेचर ना तो जीरो हो सकता बिकॉज आइस का टेम्परेचर बढ़ेगा, बिकॉज आइस इज गोइंग टू मेल्ट, उसका टेम्परेचर तो बढ़ने वाला है, और वाटर का टेम्परेचर घटने वाला है, तो ना तो इन्फिनिटी हो सकता आंसर, ना ही जीरो हो सकता आंसर. विल बी 0, 5 और 10. कैसे निकालोगे बच्चों? गाइस यू नो यहाँ पे आइस क्या लूज करने वाला है, आइस इज गोइंग टू लूज फर्स्ट इट्स व्हाट, लेटेंट हीट ऑफ वेपराइजेशन, लेटेंट हीट ऑफ फ्यूजन, सॉरी, आइस इज गोइंग टू लूज इट व्हाट, लेटेंट हीट ऑफ फ्यूजन. ओके, तो यहाँ पे मैं क्या लिख सकता हूँ, लेटेंट हीट ऑफ फ्यूजन कितना होता है आइस का, दैट इज 334 किलो जूल पर केजी. 334 किलो जूल पर केजी, बट हमारे पास कितना मास है 1 ग्राम, सो 1 into 10 की पावर -3. दिस इज द लेटेंट हीट ऑफ फ्यूजन ऑफ व्हाट आइस, प्लस इसका टेम्परेचर क्या करेगा बच्चों, बढ़ेगा. सो मास mc, लिक्विफाई होने के बाद इट विल बी कन्वर्टेड इनटू व्हाट गाइस, इट विल बी कन्वर्टेड इनटू द लिक्विड वाटर. वाटर का स्पेसिफिक हीट कितना होता है बच्चों, दैट इज क्लोज टू 4.2 किलो जूल पर केजी. ओके, इनटू व्हाट, फाइनल टेम्परेचर माइनस इनिशियल टेम्परेचर. दिस इज द इंक्रीज इन एंथैल्पी, इंक्रीज इन एनर्जी ऑफ व्हाट आइस. ये इंक्रीज है बच्चों, ये कितना एंथैल्पी, कितना हीट आइस गेन कर रहा है, दिस इज दैट. हाउ मच एनर्जी वाटर इज गोइंग टू लूज गाइस, कितना वाटर लूज करने वाला है, दैट इज इक्वल टू व्हाट गाइस, वो कितना होगा, दैट विल बी मास mc 100 minus T final. Yes or no? This is a very simple equation, guys. This is the energy gained by the ice. This is the energy lost by the water. Water का temperature decrease करने वाला है, ice का temperature बढ़ने वाला है. So, but first it is going to melt, and then it is going to what, sensible heat addition will be there for the water. तो यहां से this is common for all guys. 1 into 10 की power 3, 1 into 10 की power 3, 1 into 10 की power 3. This is common. Okay, so 334 plus 4.2 T final, that is equal to, ये आ जाएगा 420 minus 4.2 T final. इसको इधर ले आएंगे तो 8.4 T final, that is equal to 420 minus 334. इसको करोगे कितना आएगा, this will be 66 plus 70 86. So this will be T final equal to 86 divided by 8.4. अगर आप इसको सोल्व करोगे, because we have taken some approximate value of this and this, if you approximate this, definitely you are going to get the final temperature 10 degrees Celsius. That's why C is the right answer, guys, for this question. Very simple question, C is the right answer. So those answered C, they are very right. Very good, Vivek, Abhishek, Kranti, Satya, your answer is also right. पप्पू 10 का मतलब तो समझ में नहीं आया. अच्छा 10, ओके, ग्रेट ग्रेट ग्रेट. 10 मतलब 10. वेरी गुड पप्पू, आपका आंसर भी बिल्कुल सही है. चलिए, लेट अस मूव टू नेक्स्ट क्वेश्चन गाइस. क्वेश्चन नंबर 11. In an adiabatic process, 90 joule of work done on the 90 joule of work done on the gas. In an adiabatic process, 90 joule of work is done on the gas. The change in internal energy of the gas, guys. The change in internal energy of the gas. Okay. 90 joule of work is done on the gas. The change in internal energy क्या होगा, -90 +90 0, depends on initial temperature. Guys, adiabatic process में क्या होता है, dq equal to du plus dw. dq equal to du plus dw. So if process is adiabatic, this is 0. It means dw equal to minus du. Okay, तो यहां पे वर्क क्या है बच्चों, वर्क इज डन ऑन द सिस्टम, तो -90, दैट इज इक्वल टू माइनस du. तो du क्या होगा बच्चों, du विल बी 90 जूल. इंटरनल एनर्जी बढ़ेगा बच्चों. इन एडियाबैटिक प्रोसेस, इफ यू आर गेटिंग वर्क, internal energy is going to decrease. In an adiabatic process, if you are doing work on the system, the internal energy is going to increase by the same amount. So increase in internal energy will be 90 joule. B is the right answer. Next question in front of us, question number 12. Again, very simple question, guys. It's a very simple common sense question. Try to answer. One mole of which of the following has highest entropy? सबका मास सेम है बच्चों. One mole of which of the following has highest entropy? Liquid nitrogen, hydrogen gas, mercury, diamond. Highest entropy किसका होगा बच्चों? ओके गाइस, देखो मर्क्यूरी तो क्या है आपका, इसको लिक्विड मेटल बोलते हैं. तो एट ए पर्टिकुलर टेम्परेचर, एट ए पर्टिकुलर सपोज एटमॉस्फेरिक कंडीशन, लेट अस टेक एटमॉस्फेरिक कंडीशन. तो डायमंड तो क्या है, सॉलिड है. सॉलिड का एंट्रोपी तो बहुत कम होता है. ये क्या है आपका, मर्क्यूरी, ये भी लिक्विड है आपका, लिक्विड नाइट्रोजन, पहले लिक्विड बोला हुआ है इसने आपको. ओके, हाइड्रोजन क्या है, इट्स अ गैस, बहुत लाइटर गैस है बच्चों. हाइड्रोजन गैस इज वेरी लाइटर गैस. तो हाइड्रोजन गैस का जो एंट्रोपी है, इट विल बी मच हायर than the entropy of diamond and mercury if you are taking same mass. ओके, तो हाइड्रोजन का एंट्रोपी सबसे ज्यादा होगा, दैट्स व्हाई आंसर विल बी बट बी इज द राइट आंसर। चलिए लेट अस मूव टू नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 13। 13th क्वेश्चन, द एंथैल्पी ऑफ वेपोराइजेशन ऑफ ए सब्सटेंस इज दिस। एंथैल्पी ऑफ वेपोराइजेशन दिया बच्चों आपको, दिस इज एंथैल्पी ऑफ वेपोराइजेशन HFG। HFG कितना दिया आपको, 8400 जूल पर मोल। ओके, जूल पर मोल, दिस इज HFG, एंथैल्पी ऑफ वेपोराइजेशन। आपसे बॉइलिंग पॉइंट दे दिया है कितना, टी सैचुरेशन। टी सैचुरेशन दे दिया आपको, बॉइलिंग पॉइंट कितना 173 डिग्री सेल्सियस। सो 173 प्लस 273 तो कितना हो गया, इट इज 100 केल्विन। 100 केल्विन के आपका सैचुरेशन टेम्परेचर। सैचुरेशन टेम्परेचर दिया है, HFG दिया है, पूछ क्या रहा है आपसे, द चेंज इन एंट्रोपी। गाइस यू नो चेंज इन एंट्रोपी क्या होता है, change in entropy delta S, that is equal to what, HFG, heat transfer. During phase change, how much is the heat transfer, guys? Heat transfer during phase change is nothing but if you are carrying out the vaporization, that is HFG. If you are carrying out the melting, that is HIF, sorry. Okay, अगर आप sublimation कर रहे हो, that is what, that is HIG. Okay, तो sublimation करोगे तो HIG, वेपोराइजेशन करोगे तो HFG, और अगर आप करोगे क्या, फ्यूजन और व्हाट यू कैन से मेल्टिंग, तो वहां पे क्या होगा, HIF. ओके, चलिए by T saturation. तो latent vaporization कितना है, that is 8400, T saturation is 100, entropy change will be what guys, it will be 84 joule per mole Kelvin, joule per mole Kelvin. ओके गाइस, जूल यहाँ पे मैं क्योंकि मैंने पहले ही जूल पर मोल लिख दिया ना बच्चों, सो दिस इज जूल पर मोल ओनली, दिस इज जूल पर मोल, सो बिफोर दैट चलिए, बिकॉज यहाँ जूल इनटू मोल था, मैंने इसको नीचे लिख दिया, तो दैट विल बी दिस ओनली। ओके, चलिए तो आंसर क्या होगा बच्चों, दिस विल बी 84 जूल पर मोल केल्विन। ऑप्शन ए क्या हो जाएगा, दिस इज द राइट आंसर फॉर दिस क्वेश्चन। नेक्स्ट क्वेश्चन इन फ्रंट ऑफ अस, क्वेश्चन नंबर 14। A system absorbs 10 kilojoule of heat at constant volume and its temperature rises from 270 degree Celsius to 370 degree Celsius. इतना डिग्री सेल्सियस से टेम्परेचर चेंज हो जाता है। The value of delta U. How much is delta U? Read and try to answer. A system absorbs 10 kilojoule of heat. A system absorbs 10 kilojoule of heat at constant volume and its temperature rises from 270 degree Celsius to 370 degree Celsius. How much is the change in internal energy? तो गाइज ये जो चीज है ना, ये सिर्फ कंफ्यूज करने के लिए है, ये बिल्कुल कंफ्यूज करने के लिए, इसका कोई भी लिंक नहीं है। प्रोसेस इज कांस्टेंट वॉल्यूम, कांस्टेंट वॉल्यूम होगा तो dq इक्वल टू du प्लस dw। वर्क क्या होता है, रिवर्सिबल वर्क, क्लोज सिस्टम रिवर्सिबल वर्क इज pdv, और कांस्टेंट वॉल्यूम के लिए क्या हो जाएगा, 0 फॉर वॉल्यूम कांस्टेंट, फॉर ए रिजिड कंटेनर दिस इज 0। सो इफ वॉल्यूम इज चेंज इज 0, so dv will be 0, so that's why dq equal to dw, dq equal to sorry du, dq equal to du. So 10 kilojoule of heat is absorbed means this is positive. अगर ये पॉजिटिव है तो इंटरनल एनर्जी भी क्या होगा, बढ़ेगा बच्चों। In a constant volume process, if you are adding heat, internal energy is going to increase. In a constant volume process, if you are rejecting heat, internal energy is going to decrease. तो यहाँ पे आंसर क्या हो जाएगा, 10 kilojoule. B is the right answer. Next question in front of us, guys. Question number 15. Question number 15. Read and try to answer. Very good, guys. हरीश कुमार, अब ये तो नाम कुछ अलग ही है बच्चों, फिट्सम फैकडू, ग्रेट फिट्सम। B is the right answer, guys. Very good. 300 kilojoule of heat is supplied to a constant fixed temperature of 290 degrees Celsius to a heat engine. 150 kilojoule of heat is rejected at this. So source temperature दिया है आपको, सिंक टेम्परेचर दिया है, अमाउंट ऑफ हीट एडिड दिया है, अमाउंट ऑफ हीट रिजेक्टेड दिया है। आपसे पूछ रहा है साइकिल क्या है, द गिवन साइकिल इज ए रिवर्सिबल इंजन, इरिवर्सिबल, इम्पॉसिबल, रैंडम। गाइस बहुत सिंपल आसान क्वेश्चन है, यू कैन ट्राई हियर व्हाट cyclic integration of dq by t, Clausius inequality, you know, Clausius inequality, cyclic integration of dq by t, this is always less than equal to 0, guys. This is always less than equal to 0. Cyclic integration d cube by t equal to 0. This is for a what? किसके लिए? Reversible cycle के लिए. This is for a reversible cycle. Cyclic integration d cube by t less than 0, negative. This is for what? Irreversible cycle. Okay. And cyclic integration d cube by t greater than 0, it is what? It is impossible, guys. ये impossible है. This is violation. ये नहीं हो सकता बच्चों. This is impossible. Okay, so you can check it here. Cyclic closest inequality. देखो heat added क्या होता है? Positive होता है. तो cyclic integration dq by t, you can write it like this: q1 by t1. So q1 by t1 ये positive है because this is a heat addition, minus q2 by t2. q1 क्या है? Heat addition है. t1 is the source temperature, q2 is the heat rejection, t2 is the sink temperature. Heat addition positive है तो ये quantity positive है. This is rejected negative. Why? Because heat rejection is negative. तो q1 कितना है? 300 जूल. टेम्परेचर कितना है? 290. तो 290 में 73 जोड़ दो, कितना आएगा? दिस विल बी 3 एंड इट विल बी 6 1, इट विल बी 563. तो कितना आएगा? 563 माइनस 150 डिवाइड बाय व्हाट? 8.5. तो ये आ जाएगा कितना? 8.5. ये आएगा 291.5. दिस विल बी 291.5. ओके गाइस, अगर आप यहां ऑब्जर्व करो, देखो इसको ऑब्जर्व करो आप. So this is half of this. This is half of this. ये इसका डबल है. देखो इसका डबल 300 है, इसका डबल ये है. तो अगर आप इसको अगर आप न्यूमरेटर डेनोमिनेटर दोनों को 2 से डिवाइड कर दो या 2 से गुना कर दो, 2 से भाग कर दो, कुछ ऐसा समझ लो, तो क्या बन जाएगा? मैंने इसको 2 से गुना कर दिया और 2 से ही भाग कर दिया, ऐसा कुछ कर दिया. ओके, तो इसको इससे भाग किया, इसको इससे भाग किया, तो क्या बनेगा? दिस विल बी दिस ओनली गाइस. 150 by 290.5, 291.5. This is 150 by 291.5. So one is positive, one is negative. So this will come out 0. So cyclic integration dq by t is coming out 0. It means the given cycle is a reversible cycle, guys. Given cycle क्या है आपका? एक reversible cycle है बच्चों. अगर dq by t 281 guys. Yes, very good. This will be 281. Very good. 281 आएगा बच्चों. This will be 281. So yes, this will be 0. 273 plus 8.5, it will be 281.5. चलिए, good. So guys, if dq by t is coming out 0, it means the given cycle is a reversible cycle. That's why option A is the right answer. चलिए, let us move to next question. Question number 16. Please try to answer this also. 150 kilojoule of heat is transferred from a heat source of 527 degrees Celsius to a heat sink at 120 degrees Celsius. The ambient temperature 47 degrees Celsius. The loss of availability. Guys, what is this loss of availability? Loss of available energy. It is nothing but loss of work potential. Loss of work potential. Okay. It is nothing but what? इसी को क्या बोलते हैं बच्चों? This is known as irreversibility. Irreversibility. तो irreversibility क्या होता है? Loss of available energy, loss of work potential, या इसी को क्या बोलते हैं? Increase in unavailable energy. Increase in unavailable energy. और यही क्या होता है बच्चों? This is nothing but irreversibility, and that is nothing but W max minus W actual. तो एक तो डायरेक्ट फॉर्मूला आता है इसमें. लॉस ऑफ अवेलेबल एनर्जी निकालने का एक डायरेक्ट फॉर्मूला होता है बच्चों. whenever you are changing the temperature, you are decreasing the temperature of heat addition, there must be some loss of available energy. और वो क्या होता है? that is nothing but Q into TO into T1 minus T2 divided by T1 T2. तो ये तो डायरेक्ट फॉर्मूला है बच्चों. if you are applying this, then directly you are going to get the answer. Otherwise what you can do, you can find out available energy initially. पहले ही available energy निकाल लो. Q into what? 1 minus TO by T1. This is available energy. Available energy second निकाल लो. Second क्या है? Q is same. So this is 1 minus TO by T2. You are changing the temperature of heat addition. So this is the available energy initially when you are adding heat at this temperature. This is the available energy when you are adding heat at lower temperature 127. तो पहले AE1 निकाल लो 150 into 1 minus TO कितना हो जाएगा 47, so it is 330 डिवाइड बाय 527 273, ये हो जाएगा 600 800. ओके, या इसको निकाल लो 150 इंटू 1 माइनस 330 डिवाइड बाय 400. इसको सोल्व करो, इसको सोल्व करो, एंड देन इफ यू वांट टू फाइंड आउट द irreversibility, so irreversibility is nothing but AE1 minus AE2, and that is nothing but what guys, loss of work. This is the available energy which you are having initially, this is the available energy which you are having finally. So the difference is this, what, there is a loss of available energy. So you can approach, you can follow this conventional approach. Otherwise, if you are able to remember this formula, then directly you can find out the loss of available energy when you are decreasing that temperature of heat addition. So this is 150 into 330 into 800 minus 400 divided by 800 into 400. ओके, तो इसको भी सोल्व करके आप डायरेक्टली निकाल सकते हो. तो इरिवर्सिबिलिटी विल कम आउट 150 into 330 into 1 by 800, ये कट जाएगा. ओके, सो इरिवर्सिबिलिटी विल बी व्हाट, 15 45 पे जाएगा 4, फिर 45 पे जाएगा तो दिस डिवाइड बाय 8. ओके, तो अभी देखो किस पे जाएगा. So it will come out roughly close to 60 kilojoule. Approximately it will come out 60 kilojoule. तो C क्या हो जाएगा आपका, राइट आंसर हो जाएगा बच्चों. So you can use this direct formula, or otherwise you can find out AE1, AE2, and then you can get the answer 60 kilojoule. चलिए next question पे move करते हैं. Question number 17. Question number 17 guys. Question number 17. Consider the following statement. So you need to choose how many statements are correct out of these 4 statements. 4 statement अपने को given है बच्चों. इन 4 statements में से आपसे पूछ रहा है which statement is right. Please read and try to answer. मैडम ओके, अवेलेबिलिटी इज मैक्सिमम थ्योरेटिकल वर्क ऑब्टेनेबल. क्या अवेलेबिलिटी यही होता है बच्चों? व्हाट इज अवेलेबिलिटी? अवेलेबिलिटी इज अ मैक्सिमम वर्क ऑब्टेनेबल. इज इट राइट? बिल्कुल सही है, दिस इज राइट. What is Clausius-Clapeyron equation guys? Clausius-Clapeyron equation is the equation which establishes the relationship between T saturation and P saturation guys. You know the Maxwell correlation, SPVT. So dP by dt during phase change, dP by dt during phase change at constant volume, that is nothing but what? Change in entropy divided by what? Change in volume. Change in volume at what? Constant temperature. So during phase change, dP by dt, you can write it as what? Change in entropy, and change in entropy you can write it as what? HFG for a phase change divided by T saturation into Vg minus Vf. Okay, because specific term, suppose if you are writing, we are writing the specific term, so this will be like this. So this is known as what? This is your Clausius-Clapeyron equation, the equation which establishes a relationship between saturation pressure and saturation temperature. So this equation is very right, because अगर आप यहाँ पे terms को interchange करते हो, this Vg by minus Vf, if you are writing here Vg minus Vf, if you are writing here, then here you will get what? dt by dp into HFG divided by T saturation. This equation is very right. A gas can have any temperature at a given pressure, unlike a vapor. Yes. Suppose you are having a gas in the superheated region. So in the superheated region, if you are having a gas, in the superheated region, if you are having a gas at a particular temperature, at a particular pressure, suppose at a particular pressure, it can have various temperatures. So this is T1, this is T2. At various pressure, at a particular pressure, a gas can have various temperatures. Okay, but vapor, or what you can say, a liquid vapor mixture, or a vapor, liquid vapor mixture, or vapor, what you can say, in a wet region, you will not have a gas. Vapor is not going to exist at a different temperature at a particular pressure. No, vapor will have a particular temperature corresponding to a particular pressure. So a gas can have any temperature at any given pressure, unlike a vapor which has a fixed temperature at a given pressure. So this is also right. Okay, Last statement, Joule-Thomson coefficient, guys. What is Joule-Thomson coefficient? Mu JT, which is nothing but the slope of isenthalpic curve on PT diagram. So this is what the slope of isothermal curve on TP diagram. TP diagram. So this is del T by del P of what? Isenthalpic. Okay. Del T by del P, the slope of the isenthalpic curve on PT diagram. So this is temperature, this is pressure, okay, and the slope of the isenthalpic curve, this is enthalpy constant, slope of the isenthalpic curve on TP diagram, that is known as Joule-Thomson coefficient, okay. और अगर ये Joule-Thomson coefficient क्या होता है बच्चों? This mu JT, if it is zero, this is for what? Ideal gas. ये किसके लिए है? Ideal gas के लिए. तो आइडियल गैस के लिए जूल थॉमसन कोएफिशिएंट क्या होता है? 0. इट मींस इफ यू आर कैरिंग आउट थ्रोटलिंग ऑफ एन आइडियल गैस, द टेम्परेचर इज गोइंग टू रिमेन कांस्टेंट. Throttling of an ideal gas, temperature is going to remain constant. But if you are carrying out throttling of real gas, temperature can increase or temperature can decrease. Okay. If the temperature, if the gas is having positive Joule-Thomson coefficient, means something like this. Because this slope is positive, guys. This slope is negative. You can check. ये भी ढलान है, ये भी ढलान है, बट दोनों में फर्क क्या है? इसमें आप ऊपर चढ़ रहे हो तो पॉजिटिव स्लोप है, इसमें आप नीचे उतर रहे हो, सो दिस इज नेगेटिव स्लोप. बोथ आर स्लोप, ओके. हो सकता है दोनों स्लोप भी बराबर हो, बट ये क्या है? नेगेटिव स्लोप है. दिस इज व्हाट? पॉजिटिव स्लोप. सो इफ यू आर इन दिस रीजन, गाइस, if you are in this region, for example, this is known as what? A kind of inversion curve, okay. So it is a locus of various inversion points on the TP diagram. Locus of various inversion point on TP diagram, that is known as inversion curve. So if you are in this region 1, the region left of the inversion curve, तो आपको स्लोप क्या मिलता है बच्चों? म्यू जेटी होता है पॉजिटिव, एंड वी विल गेट द कूलिंग इफेक्ट इफ यू आर कैरिंग आउट थ्रोटलिंग ऑफ ए रियल गैस. बट if you are in region 2, तो mu JT क्या होता है? Negative, and we will get the heating if you will carry out the throttling. Okay, so this statement is not right, guys. Here mu is equal to del S by del P. This is not right. ये सही नहीं है. तो only statement 1, 2 and 3 are right. तो option A क्या हो जाएगा? is the right answer for this question. Okay, guys, ये गैस का प्रॉपर्टी होता है, गैस का नेचर होता है. Each and every gas is having some particular inversion temperature. हर गैस का अपना क्या होता है? Inversion temperature होता है. This particular temperature, this is known as maximum inversion temperature. Maximum inversion temperature, guys. जितना ज्यादा ये maximum inversion temperature होगा, जितना ज्यादा होगा, if a gas is having very high inversion temperature as compared to atmospheric conditions, तो अगर आप उस गैस का थ्रोटलिंग करोगे atmospheric conditions पे, we will get the cooling effect. That gas will have positive Joule-Thomson coefficient if its inversion temperature is much higher. There are some gases like helium, neon. These gases, they are having very low inversion temperature. उनका inversion temperature बहुत कम होता है बच्चों. That's why at atmospheric temperatures, we are carrying out the throttling, their what temperature starts increasing. Why? Because inversion temperature बहुत कम है. तो जो आपकी इनलेट कंडीशंस होंगी, जो इनलेट कंडीशंस हैं, वो कहां पे लाई करेंगी? इनलेट कंडीशन विल लाई इन द लेफ्ट रीजन, left of the inversion curve, because inversion temperature is very low for a gas, so inlet condition will lie in what? Left. Okay, तो वहां पे क्या होगा आपका? जब आप प्रेशर डिक्रीज करोगे इन थ्रोटलिंग प्रोसेस, टेम्परेचर विल स्टार्ट increasing, because in this region the Joule-Thomson coefficient is negative. But if a gas is having very high inversion temperature, most of the gases, they are having very high inversion temperature like oxygen, nitrogen, okay. These gases are having what? Very high inversion temperature. इसलिए when you are carrying out throttling of those gases at atmospheric conditions, we will get the cooling effect. Okay, चलिए next question in front of us. ये था हमारा 17th क्वेश्चन, एंड दिस इज द 18th क्वेश्चन. 25, 28 क्वेश्चन, गाइस, वी विल सोल्व. चलिए, व्हाट इज द रेशियो ऑफ द एफिशिएंसीज? ये एफिशिएंसीज है. यस, व्हाट इज द रेशियो ऑफ एफिशिएंसी ऑफ 1? सो दिस इज 1 साइकिल. ये पहला साइकिल है, कुछ ऐसा, ये कुछ ऐसे जा रहा है 1 2 3, ये जा रहा है 1 2 3, तो ये साइकिल कुछ ऐसा जा रहा है, ये ऐसा जा रहा है. आपसे पूछ रहा रेशियो ऑफ एफिशिएंसी ऑफ 1 and 2. 1 और 2 की एफिशिएंसी का रेशियो पूछ रहा है बच्चों. एफिशिएंसी क्या होता है बच्चों? एफिशिएंसी क्या होता है? एफिशिएंसी इज नथिंग बट W net 1 डिवाइड बाय हीट सप्लाइड 1, W net 2 डिवाइड बाय हीट सप्लाइड 2. यस और नो? दोनों का एरिया क्या है बच्चों? इफ यू विल ऑब्जर्व इट हियर, बोथ आर हैविंग सेम एरिया, ये भी एक राइट एंगल ट्रायंगल है, ये भी एक राइट एंगल ट्रायंगल है, सिर्फ उसका ओरिएंटेशन चेंज हुआ है। यहाँ पे टेम्परेचर लिमिट देखो T1 T2 T1 T2 S1 S2 S1 S2 एवरीथिंग इज सेम, तो इसका एरिया बहुत सेम है। टेम्परेचर टीएस डायग्राम पे द क्लोज्ड एरिया इज गिविंग अस व्हाट, नेट हीट ट्रांसफर, एंड नेट हीट ट्रांसफर इक्वल टू नेटवर्क ट्रांसफर। तो नेटवर्क ट्रांसफर इसका और नेटवर्क हीट ट्रांसफर इसका क्या है, दोनों का बराबर है बच्चों। सो दिस एफिशिएंसी रेशियो इज नथिंग बट हीट सप्लाइड टू, 2 में कितना हीट सप्लाई कर रहे हो, डिवाइड बाय हीट सप्लाइड इन 1, हीट सप्लाइड इन 2 डिवाइड बाय हीट सप्लाइड इन 1। अच्छा बच्चों पहले 1 को देखते हैं, क्या इस प्रोसेस में हीट एडिशन सप्लाई कुछ हो सकता है, क्या 1 to 2 कुछ सप्लाई हो सकता है? सर कैसे हो सकता है, ये तो आइसेंट्रोपिक प्रोसेस है, आइसेंट्रोपिक में तो रिवर्सिबल एडियाबैटिक है, इसमें तो हीट सप्लाई हो नहीं सकता। 3 to 1 क्लोज सिस्टम में सिस्टम का एंट्रोपी डिक्रीज कर रहा है, क्या हीट सप्लाई हो सकता है? नहीं सर, ये तो रिजेक्शन है। 3 to 1 क्या है, रिजेक्शन है। तो हीट सप्लाई कब होगा, जब एंट्रोपी बढ़ेगा। सिस्टम के अंदर आप क्या कर रहे हो, हीट एडिशन करोगे, तो सिस्टम में, क्लोज सिस्टम में इफ यू आर एडिंग हीट, एंट्रोपी इज गोइंग टू इंक्रीज। तो 2 to 3 में हीट एडिशन हो रहा है बच्चों। सो दिस इज नथिंग बट हीट ट्रांसफर, इसमें 2 to 3 हो रहा है, इसमें कहां पे होगा, इसमें भी 2 to 3 होगा। देखो ये आइसेंट्रोपिक है, ये भी क्या है, एंट्रोपी डिक्रीज कर रहा है, तो दोनों में प्रोसेस तो 2 to 3 है, बट उनके अंदर का जो एरिया है दैट इज डिफरेंट, एरिया इज डिफरेंट गाइस। इसके अंदर एरिया क्या है बच्चों, सेकंड के अंदर कितना हीट एडिशन होगा, ये वाला पूरा एरिया। इसके अंदर कितना हीट एडिशन होगा, ये वाला एरिया। यस और नो? तो ये एरिया अगर आपने लिख दिया, यू विल गेट द आंसर। चलिए तो लिख देते हैं इसको, हीट एडिशन, ये पूरा एरिया, ये पूरा एरिया कितना होगा बच्चों, ये पूरा एरिया, बिकॉज अपने को पहले लिखना है हीट एडिशन इन द साइकिल 2 विच इज नथिंग बट हीट एडिशन ds, ds equal to what, dq by t, so dq equal to tds, so it is nothing but t1 into s1 minus s2. So this is the heat addition in this process guys. Okay, heat addition in this process 2 to 3, 2 to 3 में ये वाला पूरा area, this is the heat addition. How much is heat addition in this guys, this is this area plus this area, so this is nothing but t2 into s1 minus s2, इसको भी मैं, हाँ चलो कैपिटल लिख देते हैं, इसको भी कैपिटल लिख देते हैं। सो T2 into S1 minus S2 plus this closed area, so this is nothing but half base S1 minus S2 into height T1 minus T2। तो थोड़ा सा लिखना है बच्चों, क्वेश्चन इज वेरी सिंपल। सो दिस विल कैंसल आउट, सोल्व कर देते हैं इसको। सो T1 by T2 plus T1 minus T2 डिवाइड बाय 2। ओके चलिए फर्दर यू कैन टेक एलसीएम, यू कैन टेक एलसीएम 2, तो ये 2 ऊपर जाएगा तो 2t1 डिवाइड बाय व्हाट, 2t2 प्लस t1 माइनस t2। तो एफिशिएंसी रेशियो क्या आ जाएगा बच्चों, दिस एफिशिएंसी रेशियो विल कम आउट व्हाट, एफिशिएंसी रेशियो 1 डिवाइड बाय एफिशिएंसी रेशियो 2, दिस विल कम आउट 2t1 डिवाइड बाय t1 प्लस t2। वेरी सिंपल क्वेश्चन। चलिए तो आंसर क्या होगा बच्चों, आंसर विल बी डी फॉर दिस क्वेश्चन गाइस, ऑप्शन डी इज द राइट आंसर। ओके, डी इज द राइट आंसर गाइस, प्लीज चेक, नोट बी सी इज नॉट राइट, डी इज द राइट आंसर, 2t1 by t1 plus t2। ओके चेक दिस अगेन एंड टेल मी इज इट क्लियर गाइस। चलिए तो कुछ दो चार क्वेश्चन आई पिक सम लेंथी क्वेश्चन आल्सो, यू आर गोइंग टू फाइंड आउट सम वेरी डायरेक्ट क्वेश्चन, ओके one liner also, all different kind of questions guys। चलिए next question, question number 19, question number 19 in front of us, please try this question। a heat engine receives heat from a source at 1200 Kelvin at the rate of 500 kilowatt and reject the waste heat to a medium at 300 Kelvin, the power output of the engine is 180 watt, what will be the irreversibility? Guys irreversibility क्या होता है, irreversibility is nothing but loss of work, loss of work। so this is nothing but available energy या W max minus W actual। W actual कितना मिल रहा है बच्चों, how much actual work you are getting, 180 kilowatt। W max कितना होता है, this is nothing but sir Q into 1 minus TO by temperature higher। तो निकालो इसको, W max निकाल लो, Q1 कितना है बच्चों, how much is Q1, Q is this कितना 500 watt, हाँ 500 kilowatt, 500 into 1 minus, how much is TO 300 Kelvin, divided by 1200 Kelvin. So 1 by 4, so it will be 3 by 4. Okay, तो कितना आ जाएगा? It will be 500 into 3 by 4. Okay, देखो, एक पे जाएगा, फिर दो पे जाएगा, फिर 5 पे जाएगा, तो it will be what? It will be 375. Okay, तो loss of work कितना आ जाएगा? Loss of work will be 375 minus 180, so it will be 175 or 20, it will be 195 kilowatt. ये इंजीनियरिंग सर्विसेज का क्वेश्चन है बच्चों, कुछ क्वेश्चन ऐसे भी मिलेंगे आपको. 195 किलोवाट, 195 kilowatt, this is the loss of work, guys. So how much work we are losing in that process? That is a maximum work, available energy, maximum work that we can get in a cycle by bringing the system to the dead state or atmospheric condition, that is known as available energy. So available energy minus actual work, that is going to give you the loss of work. In a reversible process, there will be no work potential loss. Whatever work you are giving, that same work you are going to get in a reversible process. There will be no loss in the work in a reversible process. Irreversibility will be zero. Entropy generation will also be zero in a reversible process. Question number 20, guys. For a steady flow process, the conditions at stage 1 and stage 2. Steady flow का मतलब क्या होता है बच्चों? It's talking about what? Open system. Steady flow क्या होता है आपका? ओपन सिस्टम, वेयर द प्रॉपर्टीज आर नॉट चेंजिंग विद टाइम, मींस एनर्जी इन इक्वल टू एनर्जी आउट, नो एक्यूमुलेशन ऑफ द मास इज टेकिंग प्लेस. तो स्टेज 1 पे कंडीशंस दी है आपको, H1 H2 दिया है, S1 S2 दिया है, आपसे पूछ रहा है अवेलेबिलिटी. गाइस अवेलेबिलिटी क्या होता है? व्हाट इज अवेलेबिलिटी फंक्शन फॉर ओपन सिस्टम? गाइस अवेलेबिलिटी फंक्शन फॉर ओपन सिस्टम क्या होता है? देयर इज नथिंग बट H minus T naught S. H minus T naught S, दिस इज द अवेलेबिलिटी फंक्शन. और अवेलेबिलिटी क्या होगी ओपन सिस्टम की? Availability for open system is nothing but what? Phi1 minus Phi2. Open system के लिए ये availability क्या होती है बच्चों? For open system this is nothing but what? Phi1 minus Phi2. क्या लिख सकते हो आप? Phi1 minus Phi2. So this is nothing but H1 minus T naught S1 minus H2 minus T naught S2. क्या आ जाएगा? H1 minus H2 minus T naught S1 plus T naught S2. S को मैं क्या लिख सकता हूं? Further you can simplify this and you can write it as H1 minus H2 minus T naught into S1 minus S2. Okay, तो बाकी remaining values you need to put. How much is H1? This is 300. How much is H2? It is 150. How much is T naught? T naught is what? It is given to us or not? 300 Kelvin. How much is S1? S1 is 1.25 and S2 is 0.28. 1.25 minus 0.8. So let's solve this. So 150 minus 300 into कितना जाएगा? 1.25 into plus 0.2, it will be 1.45. Okay, तो आ जाएगा 150 minus 3 into 145. ठीक किया हमने. Let me check the units also. Yes, so 300 minus this. Yes, minus this, S1 minus S2, so this is this minus 300. Fine. 1.25 minus this. Yes, so 1.25. Okay, it will be only 0.45, guys, not 1.45. It will be only 0.45. So it will be 0.45. Okay, so it will be 3 into 45. तो उसको सोल्व करते हैं. 150 minus, it will be what, guys? It will be 135. 135. So answer will be 15 kilowatt. 15 kilowatt. So A क्या हो जाएगा बच्चों आपका? A is the right answer for this question. So the availability for this case is 15 kilowatt. Availability is 15 kilowatt. Okay. चलिए, let us move to next question. Question number 21. Very good, guys. 21 question in front of us. जल्दी करते हैं. A heat engine receives half of its heat supply at 1000 Kelvin. Remaining half from 500 Kelvin. The heat is rejected to a sink at 300 Kelvin. The maximum thermal efficiency, guys. If he is asking you maximum thermal efficiency, it means when you will have maximum thermal efficiency, guys, when cycle will be reversible. When cycle will be reversible. So indirectly he is giving you the data, consider that given cycle as a reversible cycle, because he is asking you the maximum efficiency. So cycle is something like this. This is some source at 1000 Kelvin. This is another source at 500 Kelvin. The engine, a reversible engine, a reversible heat engine. This is receiving heat Q divided by 2 from this. 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 Okay, Q is the total heat addition. Q क्या है बच्चों? Q is the total heat addition. Okay, total heat addition कितना है? Q. Q by 2, half it is getting from this, half it is getting from this, and it is rejecting heat. QR rejection to a sink at 300 Kelvin. To a sink at 300 Kelvin. And he has given you the cycle is a reversible engine indirectly, and he is asking you the maximum efficiency. So guys, for a reversible engine, cyclic integration dq by t, this is 0 for a reversible cycle. Yes or no? So you can write it here. This is positive because heat addition. So q by 2 into 1000 positive, plus this is also positive because heat addition. So q by 2 into 500. Q by 2 into 500. This is also positive, guys. Heat addition. Minus Q rejection divided by 300. That is 0. This is 0, guys. Okay. So solving this, what you will get? You will get a QR by 300. QR by 300. That is equal to what, guys? This is what? Q by 2000 plus Q by 1000. You can take this 1000 2000 LCM. So this will be what? Q plus 2Q. So this is 3Q by 2000, guys. 3Q by 2000. Okay. Further, if you solve this will cancel out. Okay. So you will get Q rejection equal to 9Q by 20. Q rejection equal to 9Q by 20. So this is the relationship we are getting. Or from this, what you can get? You can get Q rejection by Q supplied. This is what? This Q is nothing but Q supplied. Rejection by supplied is nothing but 9 by 20. Rejection by supplied is 9 by 20, guys. And then it is very easy to find out the efficiency, because you go to the ratio of what? You go to the ratio of rejection by supplied. What is efficiency, guys? What is the efficiency of heat engine? Sir, efficiency of heat engine is any heat engine, whether reversible or irreversible, this is nothing but W net by heat supplied, or it is nothing but Q net by heat supplied. Sir, it is nothing but heat supplied minus heat rejected by heat supplied, or sir, it is nothing but 1 minus heat rejection by supplied. So here supplied is Q. Q is the total heat supplied. So efficiency will be 1 minus 9 by 20. So it will be what, guys? 11 by 20. Percentage में निकालना है, so you can multiply it by 100. So efficiency will be 55%. So efficiency of this given engine is 55%. It means answer क्या हो जाएगा? Option A is the answer, guys. Option A is the right answer for this question. Very good, guys. Those are getting 55. They are very, very right. 55% is the efficiency of this given engine. Let us move to next question. Question number 22. ये बड़ा सिंपल टिपिकल क्वेश्चन है बच्चों, बहुत बार पूछा जाता है. सिंपल क्वेश्चन है. The reading of a temperature on Celsius scale. Guys, on Celsius scale, what is the steam point? Ice point, steam point क्या होता है? This is ice point. This is what? Steam point. डिग्री सेल्सियस में क्या होता है बच्चों? डिग्री सेल्सियस में ice point is 0 degree Celsius. Steam point is 100 degree Celsius. On Kelvin scale, this is 273 Kelvin. This is what? 373 Kelvin. On degree Fahrenheit scale, this is 32 degree Fahrenheit, and this is 212 degree Fahrenheit. So what do we want, guys? We want a temperature corresponding to what? 60 degree Celsius. So this is 60 degree Celsius. इसके corresponding temperature in degree Fahrenheit we want. चलिए, so guys, very simple rule. What you can do here, 60 minus 0 divided by length of the scale is what, 100 minus 0. Here what you are having, x minus 32 divided by 212 minus 32. If you know about this rule, guys, this is very simple. Variation in temperature. So if you solve this, 60 by 100, x minus 32 divided by 180, ये कट जाएगा, this will cancel out. So x minus 32, that is equal to 18 into 60. So x equal to 98 plus 32. So this is what, 130 degree Fahrenheit. 130 degree Fahrenheit, guys. So 60 degree Celsius is equivalent to 130 degree Fahrenheit. Please check. Note D, guys. Why you are saying D? Guys, I am getting 132. Why you are getting 140? Please check. मैं भी check कर लेता हूँ. Yes, I think I am getting 130. Why you are saying D? Please check. अच्छा, मैंने गलत लिख दिया. Sorry for that, guys. Sorry for this. Okay, ये मैंने गलत लिख दिया. Yes. So this is the calculation mistake. Let me again write it here. Yes. Okay. Yes. Answer will be 140 only, guys. Yes. This is 108. Okay. 108. So this is 140 degree Fahrenheit. Okay. So x equal to 140 degree Fahrenheit. चलिए, very good. 140 degree Fahrenheit. So answer क्या हो जाएगा? Yes, D is the right answer, guys. D is the right answer for this question. D is the right answer. Very good, guys. चलिए, let us move to next question. Question number 23. Question number 23. The variation of temperature pressure with the saturation temperature of a liquid is this. So guys, this is nothing but what? This is nothing but dp by dt. ये dp by dt है बच्चों आपको. dp by dt is given to you. कितना दिया है? 0.1 into 10 की पावर 2 कर देता हूं मैं, किलो पास्कल पर केल्विन. 0.1 into 10 की पावर 2 किलो पास्कल पर केल्विन at 400 Kelvin. Guys, you know closest Clapeyron equation, dp by dt during phase change is nothing but hfg by T saturation into Vg minus Vf. So this is given to us 0.1 into 10 square into how much is latent heat transfer, guys? Latent heat दिया है आपको, वही पूछा है. तो hfg is asking you, hfg divided by how much is T saturation? It is 400 Kelvin. Vg minus Vf. So Vg is what? This is Vg 0.251 minus this is 001. अच्छा, गड़बड़ कर दिया इसने. ये यहां पे वेपर होना चाहिए, यहां पे लिक्विड होना चाहिए. सो दिस इज फॉर वेपर एंड दिस इज फॉर लिक्विड, गाइस. सेकंड वन इज फॉर लिक्विड. फर्स्ट वन इज फॉर वेपर बिकॉज हाइयर है. वेपर का स्पेसिफिक एंथैल्पी वॉल्यूम क्या होता है? ज्यादा होता है. स्पेसिफिक वॉल्यूम लिक्विड का बहुत कम होता है बच्चों. वॉल्यूम इज इनवर्सली प्रोपोर्शनल टू व्हाट? डेंसिटी. ओके, सो इफ यू सोल्व दिस, hfg will come out 0.1 into 10 square into 400 into 0.250. 0.250. ओके, देखिए 2 0 है तो इसको हटा देते हैं तो बन जाएगा 25. ये 2 0 है तो बन जाएगा 10. तो 10 गुना 25 करोगे तो कितना आ जाएगा? 250. आई एम गेटिंग दिस, गाइस. Okay, let me again check the calculation. So 0.1 into 10 square into 400 into 0.250. The value of latent heat of evaporation. I think everything I have put in. Saturation temperature liquid, the specific volume are this. Yes. So 0.051 minus 0.001. So it will be this only. I think there is some data mistake, guys. Otherwise, after calculation, you are going to get this only. 400 है तो इसको हमने हटा दिया. अच्छा, ये 2500 होगा ना बच्चों? This will be why, how we can miss 4. So 4 is also there, guys. 4 is also there. 10 4 into 20. So it will be 1000 kilojoule per kg. 1000 kilojoule per kg. Actually, initially we missed this 4. Okay, so answer will be what? C is the right answer, guys. 1000 kilojoule per kg. This is the right answer. 1000 kilojoule per kg. So using Clausius-Clapeyron equation, you will get the answer very easily for these kind of questions. Let us move to next question. Question number 24. No substance can exist in the liquid phase in stable equilibrium. No substance can exist in liquid phase in stable equilibrium. Option A, the temperature is below the critical point temperature, triple point temperature. At pressure below the triple point pressure, at pressure below the triple point pressure, at pressure above the triple point pressure, at temperature above the triple point temperature, guys. So what do you feel? What will be the answer, guys, for this question? Guys, if you draw the PT diagram for water, this kind of plot you are going to get. For water, this kind of curve you are going to get, guys. Water के लिए कुछ ऐसा कर्व मिलता है. This is for water. Fusion curve for water, and this is the fusion curve for other substances, guys. This is for other substances, others. This is the fusion curve for water, and this is the fusion curve for other substances. Okay, and what is this, guys? This is triple point temperature and triple point pressure. This is PT curve. कितना होगा? This is 0.01 degree Celsius, and this is what? 611 Pascal. 611 Pascal. This is triple point temperature and pressure. So guys, here what is asking you? No substance can exist as liquid. Guys, here what is this? This is what? This is solid region. This is solid. What is this? This is liquid. What is this? This is vapor. This entire is a solid region. This is liquid. This is vapor. Okay. Now he's asking you, no substance can exist as liquid at temperature below the triple point temperature. Guys, if you are having temperature below the triple point temperature, can we have liquid, guys, at below triple point temperature, guys? ट्रिपल पॉइंट टेम्परेचर के नीचे क्या अपने को लिक्विड मिल सकता है? डेफिनेटली यू कैन हैव लिक्विड. गाइस, व्हाट इज द टेम्परेचर ऑन दिस लाइन? द टेम्परेचर ऑन दिस लाइन is what? Triple point temperature. And what is this? This region, this particular point, suppose this particular point is at the temperature below the triple point temperature, but in which region? This is in the liquid region. So yes, at temperature below the critical point temperature, substance can exist as liquid. So this is right. अबे निकालना है कहां पे नहीं कर सकता. नो सब्सटेंस कैन एग्जिस्ट एज लिक्विड इन स्टेबल इक्विलिब्रियम. तो यहां तो कर सकता है बच्चों. एट प्रेशर बिलो ट्रिपल पॉइंट प्रेशर, देखो प्रेशर बिलो ट्रिपल पॉइंट प्रेशर, yes, this is right. At pressure below triple point pressure, no substance can exist as a liquid. If the pressure is below triple point pressure, no substance can exist as a liquid. This is right. At pressure above तो कर ही सकता है बच्चों, because this entire region, liquid region, lies above the triple point pressure. तो कर सकता है. At temperature above triple point temperature, भाई triple point temperature के तो ऊपर भी कर सकता है, नीचे भी कर सकता है liquid. Liquid can exist even more than triple point temperature, less than triple point temperature, but below the triple point pressure no liquid can exist. So B is the right answer for this question, guys. Next question in front of us, question number 25. The slope of isobaric lines on HS diagram. The slope of isobaric lines on HS diagram. Guys, HS क्या होता है आपका? HS is known as Mollier diagram. Enthalpy versus entropy diagram, HS diagram, Mollier diagram. Okay, so on Mollier diagram you will have constant pressure line, something like this. Constant pressure line कुछ ऐसी होती है. Okay, and these lines actually diverge in the superheated region. So this is constant slope, temperature constant, pressure constant. Okay, constant pressure line, this is P1, this is P2 constant, P1 equal to P2 constant. Okay, so guys, if you want to plot the constant pressure line on HS diagram, you can utilize the TDS equation. So TDS equal to dH minus VdP. So for constant pressure line this will be 0, so that's why dTs equal to dH, or ds by dh by ds, dh by ds is nothing but what? T, temperature. So the slope of isobaric line, the slope of isobaric line at a constant slope of isobaric line on HS diagram give is R directly proportional to what? Absolute saturation temperature. So D is the right answer, guys, not A. Why? From where you are getting A? D is the right answer, guys. The slope of isobaric line, on HS diagram is given by the saturation temperature, guys. And here you can check, because here the during the phase change both pressure temperature remains constant. During phase change pressure also remain constant, temperature also remain, because here temperature pressure both are constant, because we are interested in isobaric line. So pressure constant, temperature constant. So if temperature constant, slope will be constant. Different line, slope will be constant. Okay, but here as the phase changes, liquid converted into vapor, okay, then the temperature start increasing, and as the temperature start increasing, the slope increases. Slope क्या हो जाता है बच्चों? आपका बढ़ जाता है. That's why these constant pressure line, they start diverging in the superheated region due to increasing temperature. More is the temperature, more will be the slope. And here you can check, here the temperature is lesser, here the temperature is more. That's why at this particular pressure the temperature is higher, at this particular pressure temperature is lower, so slope is more. That's why constant pressure lines, they are diverging in the superheated region. चलिए, I think last two question, guys. I think yes, these are the last three questions. You can try. लास्ट के 3 क्वेश्चन है बच्चों, इनको भी देख लेते हैं एक बार. 26 क्वेश्चन. Last 3 questions in front of us. A positive Joule-Thomson coefficient of a liquid means. देखो यहाँ पे गैस होना चाहिए. लिक्विड्स के लिए तो ऑलरेडी when we carry out the throttling, because liquid throttling is associated with the flashing of some part of liquid into vapor, because when we carry out liquid throttling, some part of liquid converted into vapor. So temperature always decreases when we carry out throttling of liquids, but for a real gas, temperature can increase, it can decrease. Okay, so Joule-Thomson coefficient positive किसके लिए होता है बच्चों? We will have positive Joule-Thomson coefficient for what? When the temperature is going to decrease, cooling होगा बच्चों, temperature drop during throttling. अगर Joule-Thomson coefficient mu Jt पॉजिटिव होता है तो टेम्परेचर रियल गैस के लिए क्या करता है? डिक्रीज करता है. अगर म्यू जेटी नेगेटिव होता है तो टेम्परेचर बढ़ता है. म्यू जेटी अगर जीरो होता है तो टेम्परेचर क्या रहता है बच्चों? कांस्टेंट रहता है. सो फॉर ए गैस, इफ यू आर गेटिंग सम क्वेश्चन कि फॉर ए गैस टेम्परेचर इज गोइंग टू व्हाट? इंक्रीज, डिक्रीज और रिमेन कांस्टेंट. सो फॉर ए गैस टेम्परेचर कैन इंक्रीज, डिक्रीज और रिमेन कांस्टेंट. For a real gas, it can increase or decrease. For an ideal gas, it is going to remain constant. And for any gas in general, temperature can increase, decrease or remain constant. It depends on the Joule-Thomson coefficient. Question number 27, guys. Which of the following is a low grade energy? Guys, high grade का मतलब क्या होता है? A high grade energy is not having any entropy association with it, like the flow of current. Flow of current. Okay. Current कैसे flow करता है? Suppose this is any load. Okay, this is any kind of load. Okay. Current कहाँ कैसे flow करता है बच्चों? Positive to negative in a particular direction. Air कैसे flow करती है? Air kinetic energy in a particular direction. Potential energy. So kinetic energy, potential energy, all molecules, they move in a particular direction. So they are having very organized motion. Flow of current, kinetic energy of air, potential energy of air. A shaft is moving with some velocity, some kinetic energy. So the motion of the shaft is a very organized motion. So shaft power, kinetic energy, electric current, wind energy, all are very high grade energy, because each and every particle, they are moving in a very organized manner. But if you take into consideration thermal energy, heat. So heat or thermal energy, due to that, there is a huge randomness is there in the molecule, and all molecule, they are not having any kind of organized motion. Some particle moving in this direction, some are moving in this direction. So that is known as what? Entropy, randomness. So in this case, there is no randomness, there is no entropy association. That's why work is considered as high grade energy. So work is a very organized form of energy. It's like that each and every particle moving in a very organized motion, a one directional motion we are having of the molecules. But here also kinetic energy, one direction motion. But in case of thermal energy, the motion is not organized. That's why it is known as low grade energy, and that's why with heat there is huge entropy association, and that is the reason complete heat conversion into work is not possible, whereas work conversion into heat is possible completely. That's why mechanical work, electric work, kinetic energy, these all are high grade energy, and only heat energy is the low grade energy, guys. Low grade energy. Last question in front of us. This is the last question, guys, for the today's session. Again we will meet. I think we will have 4 or 5 classes for thermodynamics. Some are on YouTube, some will be through Zoom. Okay, chaliye. A system of 100 kg mass undergoes a process in which its specific entropy increases from 0.3 kilojoule to 0.4 kilojoule. सिस्टम का एंट्रोपी चेंज कितना है बच्चों? हाउ इज द एंट्रोपी चेंज ऑफ सिस्टम? सिस्टम का एंट्रोपी चेंज कितना है बच्चों? दैट इज 0.4 minus 0.3, that is 0.1 kilojoule per kg. This is the entropy change of system, positive. How much is the entropy change of surrounding? Entropy change of surrounding -5. You can check 80 70. This is initial, this is final. तो फाइनल क्या कर रहा है? डिक्रीज कर रहा है, -5 किलोजूल पर केजी केल्विन. ओके, किलोजूल पर केल्विन. यस, दिस इज एंट्रोपी चेंज. हाँ ठीक है, चलो. Okay, this is entropy change of system, this is entropy change of surrounding. What is asking, guys? What is asking in this case? A system of 100 kg mass undergoes a process in which, अच्छा इसके मैं ऑप्शन दे देता हूं बच्चों, इसके ऑप्शन नहीं है. The given process is what? Option A, irreversible. Option B, reversible. Option C, reversible and isothermal. Option D, irreversible and isothermal. Okay, these are the 4 options, guys. The given process is ये जो given process है, ये reversible है, irreversible है, reversible and isothermal है, irreversible and isothermal है. तो guys isothermal तो कहीं से भी नहीं है, बिकॉज टेम्परेचर क्या है आपका, यहां पे अगर आप देखोगे अंडरगोज ए प्रोसेस, आपका सिस्टम का एंट्रोपी चेंज कर रहा है, सराउंडिंग का एंट्रोपी क्या कर रहा है आपका? चेंज कर रहा है. तो अगर आप सिस्टम सराउंडिंग का एंट्रोपी निकालें, एंट्रोपी चेंज ऑफ यूनिवर्स इज नथिंग बट एंट्रोपी चेंज ऑफ सिस्टम, एंट्रोपी चेंज ऑफ सिस्टम प्लस एंट्रोपी चेंज ऑफ सराउंडिंग. तो क्या आ जाएगा? इट विल बी, सिस्टम के लिए कितना बच्चों? इट इज इंक्रीजिंग बाय 0.1. It is increasing by 0.1. Okay, and for surrounding it is what? Decreasing by 5. It is decreasing by 5. Okay, मेरे ख्याल से एक्चुअली में यहाँ पे क्या होना चाहिए था, यूनिट का कुछ गड़बड़ है. यहाँ पे यूनिट क्या देना चाहिए था उसको? यहाँ पे ठीक है, दिस इज किलोजूल पर केजी केल्विन. सो मास अपने को दिया है, वी कैन मल्टीप्लाई इट विद मास, इसको हम मास से मल्टीप्लाई कर सकते हैं. आई थिंक दिस मस्ट बी इन व्हाट? किलोजूल पर केजी ओनली. किलोजूल पर केल्विन, गाइस, दिस मस्ट बी इन किलोजूल पर केल्विन. एंट्रोपी चेंज ऑफ द सराउंडिंग. तो जो सराउंडिंग का एंट्रोपी चेंज है, मैं इसको ठीक कर देता हूं. दिस इज रिक्वायर्ड टू बी लाइक दिस, किलोजूल पर केल्विन, किलोजूल पर केल्विन. ओके, सो दिस इज -5. तो इसको हम क्या करेंगे? सो दिस इज इन किलोजूल पर केजी, दिस इज इन किलोजूल पर केल्विन. सो यू नीड टू मल्टीप्लाई दिस विद मास. सो मास इज 100 into 0.1 -5. तो कितना आ जाएगा? It will be 10 minus 5, so 5 kilojoule per Kelvin. 5 kilojoule per Kelvin. So entropy of the universe is increasing. Universe का entropy क्या कर रहा है बच्चों? Entropy of universe is increasing. That's why the given process is what? A irreversible process. That is the principle, increase in entropy of the universe. Principle, guys. Principle of increase in entropy of the universe. Entropy of universe can never decrease in any real process. Universe का entropy क्या करता है बच्चों? Always increases. Okay. Entropy of universe negative, it cannot decrease, but for system entropy can increase decrease. For surrounding also entropy can increase decrease. It depends on the process, whether you are adding it, rejecting it. But for universe, definitely entropy is going to increase. Decrease in entropy of universe is impossible. That is second law of thermodynamics. Chale guys, so these are the 28th question we have solved for the today's session. I hope you solved most of the question, and even if you are unable to solve, I hope you got some idea. some concepts you revised through this session. I think we had a session of 1 hour and 30 minutes, and all these 20, these are not a kind of similar questions we have solved, guys. Different question we have solved. Okay, some are difficult also, some are easy also, some are very easy like one liner also. Okay, I hope you are going to like this session, and yes, again we will meet and we will have some more discussion, some more questions we are going to solve from this subject thermodynamics. चलिए तब तक प्रिपेयर करते रहो, रिवाइज द थिंग्स, एंड इन केस ऑफ एनी क्वेरी, एनी डाउट, you can shoot your query. If you are associated with us, you can shoot your query directly to me through your WhatsApp contact, or if you are not associated, you can shoot your query in the comment section. Surely, definitely I will get back to you. Thank you, keep preparing, good luck.